Hello and welcome to Chapter 10. Now we're going to talk about our third kind of collection called tuples. But tuples are really a lot like lists. There's not too much to them. They're really kind of reductionist version of lists. So they function very much like lists in that they have things, and the difference is there are no square braces. There is a parenthesis, round brace or whatever, and they have positions 0, 1, and 2, just like a list. And you can look things up, x sub 2. So x sub 2 is actually the third element here, and so that prints out Joseph. You can assign, make a tuple here. This is the constant syntax for a tuple, and print that out, and the print statement shows you that this is a tuple, not a list, by showing you round parentheses. And a whole bunch of functions that work with lists work the same way with tuples. You can put a tuple at the end of an in statement in a for, as you might expect, and then it iterates through the tuples. Tuples maintain order, so it prints out 1, 9, and 2. So literally this bit of code here could be identical whether it was a list or a tuple. It really would do the exact same thing. The difference between tuples are that they are immutable. Once you create the tuple, you can only sort of assign a tuple, but you can't modify it. You can modify a list. So if we take a look at a list here, we make a list that's 987, and we say x sub 2 equals 6. Well, that just means this 7 becomes a 6, and that's just natural, meaning we can reassign slots. We can delete things, we can insert things, we can mutate them, we can change them, so they're changeable. Right? They're changeable. But if we try to do that same thing with a string, so we say y equals ABC, and we know that this is position 0, 1, and 2, but if we try to say, let's change the C to a D by saying y sub 2 equals D, that is not allowed. And it says it doesn't support item assignment, and this little bracket, x sub 2, is what they call item assignment inside of Python. And so if we do the same thing then with a 3-element tuple, put that in Z, and we try to change this slot to be a 0, it's going to blow up because it's the exact same thing. And that has to do with the fact that once this assignment is made, this is not modifiable. Now, it turns out that the reason it's not modifiable is for efficiency. They take up less storage, they are quicker to access, and they're really designed internally behind the scenes in ways we don't really need to understand. They're just more efficient than lists. If all you want to do is store a list and look at it and then throw it away, you probably should use a tuple instead. So there's a lot of things that you can do with lists that you also can't do with tuples, but they're really just a corollary of this notion of non-mutability. And so, like, you can sort a list, but you can't sort tuples. You can add a 5 to the end of 3, 2, 1. Can't do that in a tuple, but you can in a list. And flip the order. ... So anything that you can do to a list that modifies the list, not allowed for tuples. And so you can take a look at the kinds of things that are inside, the methods that are part of each list: append, count, extend, index, insert, pop. Many of these are modifying, and then count and index are the only ones that work for tuples. And so tuples are limited lists. Now, at some point, there's going to be a but here to say, why do we like them? And the reason that we like them is that they're just more efficient. They don't have to build Python in its own internal organization of these objects. It knows that they'll never be modified, because when you make a tuple, you as the programmer are saying, I'm never going to modify this, and Python won't let you do it. So it's higher performance, better memory use, and to a beginning programmer that doesn't really matter, but that's the reason. And so we tend to use tuples when in situations where we're going to make a temporary variable and then temporarily use it just a little bit and then throw it away without really messing with it. And we tend to use lists to build things up, etc., etc., etc. So the other thing that's interesting about tuples, and we've actually sort of seen this, is that you can put a tuple that includes variables on the left side of the assignment. And this takes a little getting used to, but it's really cool, and no other language that I know of does this. So if we say x comma y, that's a 2-tuple. Both have to be variables. You can't put constants on this side. It's like saying x equals 4, y equals Fred, right? So what happens is you can put a tuple on the far side of an assignment statement, and the 4 goes to x, and the Fred goes to y. And you say, what's in Y? Well, Y is indeed Fred. And so this is like 2 assignment statements. Now, the way I've got this syntax, I would probably do, 2 separate statements, just not to show off that I know how to do tuples. And so you can, here's another one, and they just move correspondingly. If you don't have 2 here and you do have 2 here, well, if you have 3 here, or 2 here and 3 here, and you don't match the number there, you get in some trouble. Now, if you just say x equals tuple, then that is the tuple in the list. But this is just a simple straight 99 value going into A. So you can put tuples as the left-hand side, and you can even do things like return a tuple from functions. That's a real nice Python feature that I like a lot. Tuples are also related to dictionaries, as we've seen in the previous chapter. So here we make a little dictionary. We make an empty dictionary by constructing an empty dictionary, stick it in D. So D is sort of like this place that can hold key value pairs. And we put csev, and there's a 2 in there, and chen-wen, and there's a 4 in there. So we have this, associative mapping between csev and 2 and chen-wen and 4, all stuff we know. And now we say, hey, we're going to loop through the key value pairs here, and we've seen this syntax before, k comma v. So this is a tuple. So you can think of this as each one of these things is going to get assigned into this tuple, which means the key ends up in, and the first one's the key and the second one's value. I use the variable key kv all the time in code that I write, just for my own sanity. So kv are going to iterate successively through the successive keys and values in that. So this is going to run twice, and k is going to be csev 2 and chen-wen 4. The order just happened to stay the same. And so if you say what is in one of these things, you can actually take d.items, the items method within that dictionary, and say, hey, give that to me back, and then print tups. And it's a special kind of a class, but really ultimately it is a list of tuples. This is 2. This is the 0, and this is the 2, the 1, the first and the second. And then within each thing you get, you have a 2 tuple. And so, in a sense, this k and v are iterating through those things when we're putting d.items here and d.items there. One nice thing about tuples is that they're comparable. They're comparable in the same way that strings are comparable, meaning that they're compared from left to right, with the leftmost or 0 tuple being the most significant. And it doesn't compare any further than it has to if it's asking less than. So if it's looking at, say, this first tuple, it starts at the left and says, okay, ask the question, tell me true or false. Is 0 less than 5? The answer is true. And so the answer to this overall expression is true, and it doesn't even compare those 2 numbers, those second and third number. They don't compare them. If, on the other hand, we're asking, is this less than that, it only looks at the first one and asks if it can answer the question. And the answer is, well, they're both 0. And so I can't answer the question, so I have to go to the second pair, and 1 is less than 3, and so that means this is true. And it does not check this. Even though 20 million is bigger than 4, it doesn't matter, because these are the numbers that cause the true to happen. And the same is true if you do this with strings. Again, we start the first one. So Jones, Sally, well, that's the same, so we don't know the answer yet. And so Sally, Sam, well, okay, S, oh, they're the same. A, they're the same. O, L, and M. L is less than M, so the actual letter that makes the difference here is the L and the M, and leads to us being true. And so it goes left to right, but then even when it's doing strings, it's going left to right. That's just how string comparison works. And if we say is Jones, Sally greater than Adam, Sam, well, we check the first one, and we check the J and the A. Well, J is greater than A, and so we don't have to look at anything else. We don't have to look at any more of these characters. We don't have to look at the second thing in the tuple. We have to look at that is enough to be true. So it only scans until it has a definitive answer. It doesn't scan any further. So now what we're going to do is use this comparable capability to sort these lists of tuples, and then bring this all back and connect it more to dictionaries.